I'm Alex Gray. My company is Somaxis. We make a wearable sensor that measures your heart, your muscles, your brain, your respiration, movement, and position with real-time feedback and behavioral retraining programs. The base layer of a wearable sensor is the hardware. It has to be effortless and transparent. The middle layer is firmware. The algorithms and metrics have to be meaningful and consistent. The top layer, though, is the one that is usually lacking, and that's software. There must be training programs and proven protocols that effectively induce behavior modification and fundamental shifts in quality of life. I'm one of the only people on the planet who grew up with muscle sensors as an integral part of my life from day one. In 1978, my dad created a training protocol using muscle sensors in order to treat people with repetitive strain injury, carpal tunnel syndrome, and other kinds of cumulative trauma disorders. In essence, he developed a way to retrain the stress response. He liked to say that our bodies just aren't adapted to be in fight or flight mode for days, weeks, months, or even years. And that's exactly what happens in our lives due to stresses at work. Our bodies don't know the difference between a saber-toothed tiger and a deadline, except the tiger goes away quickly or kills you. Either way, your body won't suffer for long. Stress is a state of mind. Tension is a state of muscle. Using wearable sensors and behavioral retraining protocols, you can interrupt the fight or flight response. You can control your muscles from going into bracing patterns. You can control your respiration and heart rate variability. You can reduce your blood pressure. You can increase temperature to your extremities. Sweating decreases, pupils contract. The animal instinct is overcome. We all know that stress can cause tension. However, there's a secret here. It goes the other way too. If you eliminate tension, stress is also greatly reduced, almost involuntarily. The two are so closely coupled throughout our lives that voluntary muscle control reduces psychological stress. We become calmer, happier, and make more rational decisions. There's a Greek expression, nous iei in somatini iei, a healthy mind and a healthy body. Note, it's not a healthy body and a healthy mind. The body comes first. That's what's easier to control, and if you start with the body, the mind follows. When my family was using muscle sensors to help people with repetitive strain, I never considered the broader ramifications of such training. They weren't just treating injuries. They were teaching us how to bypass our stress response. This is one thing that animals can't do. Being humane in the face of threats is, in my opinion, what defines our humanity. Of course, that means that many Homo sapiens aren't actually human. But we all have that potential, and wearable sensors can help us get there quickly. Working with SEMG biofeedback and the operant conditioning model for bypassing the stress response in 1978 was a biohack, perhaps one of the first times a sensor was effectively used for the purposes of biohacking. It wasn't, however, the first time that this ability was discovered. Yogis, martial artists, monks, and even athletes have been controlling their stress response and directly controlling their base physiology literally for millennia. However, it traditionally took at least a decade of training to learn these techniques. With muscle sensors and behavioral retraining, my parents could retrain anyone how to bypass their stress response in 12 hours. At its best, this is what wearable computers like biosensors can accomplish. They can help us choose to quickly modify our own behavior in such a way as to improve our quality of life. We can choose not to be stressed. We can control our mood. We can make more rational decisions. We can optimize our health. We can optimize our fitness. This abstract layer of reasoning is what animals lack. They react to stresses. We can choose not to react to stresses and to modify our behavior voluntarily, not through just involuntary circumstantial conditioning. We can choose to be humane even when we perceive a serious threat. And we can learn these skills without putting in a decade or more of isolated training on top of a mountain somewhere. We can learn these skills quickly and easily with wearable sensors. We can integrate this learning into our children's education, so it's always an integral part of who they are from day one. This is the future of wearable technology. It's not tech for the sake of tech. It's tech that makes us more human. Thank you. So I think I have a couple minutes.
Any questions? We'll take a couple minutes and then move into the next topic.
You said that it provides feedback for altering behavior. Mm-hmm. What sort of feedback? What does it tell you to do?
So that's a really great question. And there's different ways of giving people feedback, right? You can give them audio feedback. You can give them a visual cue. The audio feedback could be a tone. It could be a voice, a pre-recorded voice of yourself or some third party or a loved one giving you some instruction. We also have a haptic feedback driver on it, so it can actually just buzz and vibrate. So we're looking at integrating it, for example, into a hat, so that you could just put on a baseball cap or give it to a child to put on in school, and when they lose focus or attention, it would just give them a little vibration, a little buzz. So I think the key to feedback is something that no one else can perceive, because if it's feedback that everyone else knows you're getting, then you're not really going to be doing it out in the wild. And I think that's where the real learning occurs. Like, you need to have just some kind of cue. And there's certain kinds of cues that you could get, like if you're training at home with your own piece of software, that could be really sophisticated and give you more kind of specialized instruction. But then ultimately out in the field, once you know what to look for, you just need some kind of cue that's telling you, hey, right now you are in this like engaged level of stress, or right now you are losing your focus, or right now your respiration is very fast and shallow. So as long as you know what to look for, then any kind of cue can trigger that once you have the initial training. Yes?
And then you provide this training on how to deal with it? Because I know when I'm stressed, it's just...
Absolutely.
Okay.
Absolutely. So in fact, the operant conditioning protocol that I was telling you about is this complex process where you start with really simple tasks. Operant conditioning is based on rewards for successive accomplishments, not the final behavior you want to achieve, but milestones along the way. So if your goal is to be in a stressful environment where you have 5 different things going on at the same time, and your boss is yelling at you, and your kid on the phone or whatever, you start by doing really, really simple tasks and progressing to get to the point where you learn how to isolate that response. You start by sitting, then you learn how to transition from sitting to standing, then you learn how to type. You're relearning a lot of the basic behaviors, going from the simplest to the most complex, with this type of feedback and training along the way. And what's interesting is your body will try and fool you. So frequently you will get, as you start to recalibrate your muscle tension, your muscles will elongate and release lactic acid, and you will feel sore. So it almost like it's giving you negative feedback that's like, hey, if I tense back up right now, I'm actually going to feel better. So you do need someone to be telling you what to expect from your body. You need that element of training that goes along with it. Once you have that base layer of training, then just a passive feedback mechanism can help reinforce that. But the training is really critical. That's actually how you learn. It's not just from the data that's coming from a device. Last question?
We'll make this the last question.
Hi. So the muscle, you're looking at the active stiffness, the passive stiffness. What kind of, you're looking at the skeletal muscle stress, or you're looking at the EEG indicator for stress? What are you looking at?
So it's a great question. You can actually get stress from all of those things, and you can measure stress from EEG. You can measure stress from your EKG. There's some really great new metrics out there for measuring the sympathetic to parasympathetic nervous system activation ratio from an EKG signal, which is pretty cool. One of the things that we were traditionally doing in the past was just using a certain muscle group, and it turns out that the upper trapezius muscle group is one of the key indicators of stress, because every mammal on the planet, when we become stressed, involuntarily do this. And that's not just humans, as it turns out. So it's a really, really great way of, with a simple placement, being able to monitor that response.
So it's EMG.
That particular one is EMG, yes. So the sensor we're working on is a broad spectrum electrophysiology sensor, so it does EEG, it does EMG, it does EKG, and there's a 3-axis accelerometer. And you can extract respiration from an EKG signal, too. Thank you.
Thank you.